this session, we'll apply scientific notation to basic math operations. We're going to talk about multiplication, division, even a little addition and subtraction. Now, I'm sure that excites you, especially since you think you've known those operations for a decade or longer. Well, working with very large or very small numbers, there are a few idiosyncrasies we're going to look at. And the first place is, why would we do that? We would use scientific notation many times, even though we have a calculator available, because the very large numbers, the extremes, very large, very small numbers, will get lost very quickly in a calculator where you're using the exponent function. Secondly, it allows you to check your answers, because if you just put numbers in a calculator, you get a result, and the phrase is garbage in, garbage out. And the third thing, I think, is that you see the flow of the problem. When you're solving a problem, doing dimension analysis, you will be actually working with the numbers in scientific notation. These numbers to the right, for instance, could have dimensions attached, or labels attached to them, or units we call them. So let's start out and check out a couple of these numbers. 2500. Now this is not a real extreme number, but when we put that in scientific notation, we have one digit to the left of the decimal point. That will become 2.5 times 10 to the 3. Or if we take this number, 0.005, that would be equal to 5 times 1, 2, 3, 5 times 10 to the minus 3. Again, one digit to the left of the decimal place. When we multiply these, 2.5 times 10 to the 3 times 5 times 10 to the minus 3, this is the operation. With the coefficients, you multiply just as you normally do. 2.5 times 5 will give us 12.5. And when we multiply the exponents, we add them. In multiplication, you add them. So a 10 to the 3 added to 10 to the minus 3 is 10 to the 0. So this answer is simply 12.5. When we divide, and we'll just throw a number in here very quickly, 10.7, and we're dividing by the coefficient 10.3. We proceed as in subtraction. 10.7 minus the 7 minus the 3 would be 10 to the 4th. Okay, so addition is a more interesting problem, I think, because we can very quickly be confused. If we have 3 times 10 to the 2, and we're going to add 4 times 10 to the 3, and if we're going to add these together, the first inclination is to look at 4 and 3 and say, 7. But you have to watch the powers of 10, because they set the place. They set where the decimal point is. And I'm going to prove that by showing you there's no 7 there, by simply translating these back into standard notation. 10 to the 2 is 100, so this becomes 300. And we're adding 10 to the 3 is 1,000 times 4. We're adding 4,000. Notice I'm going to put the decimal point right there. Understood. Because when we add these now, you get 4,300. So we know adding 300 to 4,000 is 4,300. But if you look up here, there's nothing like that. What we do, if you want to do powers of 10, is convert them so you have the same power of 10. Let's make 3, make that a factor of 10 smaller, 0.3. And this then it becomes, to not change the value, a factor of 3 larger, 10 to the 3. And then this still stays 4 times 10 to the 3. Now when you add these, you have 4.3 times 10 to the 3, which is what this number is over here. 4,000 is 4.3 times 10 to the 3. Subtraction would be the same thing. You must have the same power of 10 when you're going to add or subtract, because they set the place. They set the number of decimal places. Now let's go back to this problem. In this problem, you are going to have 2.5 times 10 to the 3. We're going to put this in scientific notation. 1, 2, 3 times 5 times 1, 2, 3, 5 times 10 to the minus 3 over 1 times 10 to the 4. 1, 2, 3. Well, 10 to the 3. Okay, I want to make this a 0 up here. This doesn't, I hope this didn't, because I want to make that 10 to the 4. Okay, follow me. And this one now is 4 times 10 to the minus 2, all divided by 5 times 10 to the 3. Okay, when we multiply, the coefficients, we just multiply. 4 times 1 is 4, times 5 is 20, times 2.5. So we get, we'll do it this way. It becomes 50 times 10 to get the coefficient, or the exponents. 4 and 3 is 7, minus 3 and minus 2 is minus 5. So we have a total of 10 to the 2 divided by 5 times 10 to the 3. If we want to, we wouldn't have to. We can make this 5 power of 10 smaller, and that's so we see the neat little gimmick that I just did. I made this whole thing equal 1. You could just do it straight out here. 10 divided by 10 to the minus 3, 10 to the minus 1 would give you the same thing. Okay, so the operations, multiplication, division. Multiplication, we add the powers of 10. Division, we subtract powers of 10. Addition and subtraction, we set the powers of 10 if we're adding 2 or 3 numbers so they have the same power of 10, so that we can keep the decimal point correct in the addition or subtraction. Now we'll stop right there, and you may want to go to scientific notation, the introduction, or go to significant figures.